Hey guys, welcome back. In the last lesson, we saw what is Sqoop, its purpose, and its advantages. We also saw simple instructions to import a table in MySQL database to HDFS. In this lesson, we'll see some more custom import instructions and how we can use Sqoop to import files in different file formats. Take a look at this slide. I mentioned in the last lesson that during import, to find the data boundaries, Sqoop will find the min and max of the primary key in the table and will distribute the data between 4 mappers by default. Let's say you have 10 records in the stocks table. Sqoop could assign the data boundaries as shown on the slide. So mapper 1 gets ID greater than or equal to 1 and ID lesser than 4. Similarly, mapper 2 gets ID greater than or equal to 4 and less than 6, so on and so forth. At runtime, the data boundaries may not be the exact same data boundaries as shown on the slide, but you get the idea, right? Now, if the records in the table is often deleted, you might experience some mappers working with a lot of records and some mapper with very small number of records. Take a look at this illustration. Now, stocks table has only 3 records with ID 1, 2, and 10, and the remaining records are deleted from the table. And when we execute Sqoop import, Sqoop will find the min and max values of ID and will again end up with 1 and 10. And if Sqoop uses the same data boundaries, we will have mapper 1 processing records 1 and 2 and mapper 4 processing just records 10, whereas mapper 2 and 3 will not process any records. So the lesson here is, at runtime, Sqoop will only look at the min and max numbers of the primary key column and not the actual number of records between the min and max numbers. So we need to make sure to instruct Sqoop to use a column which has a pretty good data distribution to decide the data boundary, so we can distribute the records evenly across the mappers. So how do we instruct Sqoop to use another column to decide the data boundary? It is very simple actually. Simply specify the column which you like to use to decide the data boundary in the split by option. In our specific use case, since the stocks table will have records for each trade date and records from each day will be more or less the same, trade date column would be a good column to split the records by. Since in our example, we have data only for one trade date, I'm going to instruct Sqoop to use the volume column to decide the data boundaries. So in the split by option, I've specified the volume column. So let's execute this Sqoop import. Let's wait for the execution to complete and then let's review the output. The execution is now complete, but if you go up top, you can see the data boundary is decided using the volume column and the min and the max numbers are computed from the volume column. This is exactly what we needed. If we did not specify the volume column using the split by option, ID column would have been used to calculate the min and the max numbers. And as usual, this Sqoop import processed all 10 records. But again, the only difference is the data boundary is decided by using the volume column instead of the default ID column. Now let's say you have a dividends table like this right here. The dividends table has 3 columns: symbol, dividends date, and dividends amount. And the table records the dividend information for the given symbol on a given day. Now, if you need to import data by joining 2 tables, that is the stocks and the dividends table, you can do that very easily by writing a query. Just use the query option and supply your entire query like this. Since you're using a custom query here, and also you have asked Sqoop to use the volume as the split by column, you need to provide a placeholder for Sqoop to inject the additional where condition at runtime. And as you can see, we have included a placeholder $conditions, and this will be replaced by the data boundary restrictions at runtime. That is, the volume greater than or equal to a number and less than or equal to a number. So the rest of the instruction is pretty much the same. So let's go ahead and run this instruction. The job is now complete, and you can see here only 3 records were retrieved because we have only 3 records in the dividends table and we did an inner join between the stocks table and the dividends table. Let's go ahead and look at the imports target directory. You can see here there are 4 output files, which means the Sqoop import executed 4 mappers. Looks like the first mapper and the fourth mapper processed records, but the mapper number 2 and 3 did not process any records because the size of these 2 files are 0. Okay, let's move on. So far, we saw how to import data from table using Sqoop with different options in standard text format. Let's see how to import tables in compressed, sequence, and Avro file formats. Look up the file format chapter for more details about the file formats. Let's look at compression first. Importing a table into a compressed file is very simple. Just specify the compress option and by default the output file will be compressed in gzip format. That is it, it's just simple. You don't have to specify anything additional to compress your file. All it takes is to mention the compress option in your import instruction. So let's go ahead and run this import. The MapReduce job is now complete. Now I'm going to go ahead and look at the imports target directory. So let's go into this folder. As you can see, the output files here has .gz as file extension, denoting it is gzip compressed. So let's go ahead and open one of the file. There you go. It is clearly compressed and hence not in a readable format. Let's move on to sequence file. To import the file in a sequence file format, all we have to do is mention the as sequence file option. And that is it. When we execute this import instruction, the table will be imported into a sequence file. So let's go ahead and run this instruction. The MapReduce job is now complete. Now let's go ahead and look at the target directory. We will see 2 files in the target directory because in the instruction we have instructed Sqoop to use 2 mappers. So let's do a directory listing. And as you can see, we have 2 files here. So let's open one of the file. And again, it will not be in a readable format because it is in a sequence file format. And there you go. You can see in the file header, you have SCQ. And that denotes a sequence file. Okay, let's now move on to Avro files. Again, importing a table into an Avro file is very simple. All you have to do is just say as Avro data file in your Sqoop import instruction. So let's go ahead and execute this Sqoop import. The MapReduce job is now complete. Let's go ahead and verify our output. Let's do a directory listing first. There you go. We see 2 files here, 1 for each mapper. So let's do a cat on one of the file. And there it is. Again, we have a file which is not in a readable format because it is an Avro file format. So to summarize, in this lesson, we saw how to provide custom join queries to import data from tables. We also saw how to specify a custom split by column to distribute the data evenly when the primary key of the table does not provide an even data distribution across the mappers. In addition to that, we saw how to import data into sequence, compressed, and Avro file formats. In the next lesson, we'll look at Sqoop jobs and incremental import options. See you in the next lesson.